Hello, and welcome to another edition of MasterTech. Today, we're going to cover the design, operation, and service procedures for the all-new A500 transmission. The A500 was designed to fill a need for buyers interested in increased fuel economy. The A500 begins as a modified A999 three-speed load-flight automatic transmission. Then, an overdrive unit in place of the former extension housing provides fourth gear in an overdrive ratio. This transmission is designed for use with the 3.9-liter V6 in 2- and 4-wheel drive N trucks, namely the Dakota, and B-Ram vans and wagons and D-Ram pickups with the 3.9-liter V6 or 5.2-liter V8. This overdrive unit is designed for truck use and is capable of handling up to 400 foot-pounds of torque. The A500 is 6.5 inches longer than the A999, and it's about 50 pounds heavier. The other major feature of the A500 is this lock-up torque converter. The lock-up torque converter is electronically controlled and hydraulically activated. Lock-up will occur only in fourth gear overdrive and under conditions determined by the single module engine controller. A switch on the instrument panel will prevent fourth gear and torque converter lockup operation. This is desirable when towing or when climbing steep grades. This switch will automatically turn off whenever the ignition is turned off. If lockout is desired, push the switch after every startup. Other modifications of the A500 include the output shaft of the three-speed portion is now referred to as the intermediate shaft, and the overdrive shaft is now the output shaft. The governor and speedometer drive have been moved to the rear of the unit. The overdrive case now contains two bearings. One is the output shaft front bearing, and the other is the output shaft rear bearing. There are no rotating seal rings or pressurized oil for the overdrive and direct clutches in the overdrive housing. The governor is the only component receiving pressurized oil through these slip-fit tubes. Governor pressure and overdrive pressure taps are provided in the rear of the main case for in-vehicle testing. The valve body has been modified for use in the A500 by adding several new valves. There's an overdrive solenoid, a 3/4 shift valve, a 3/4 timing valve, a 3/4 accumulator, and a 3/4 shuttle valve. Once in fourth gear, the lock-up solenoid, lock-up valve, and lock-up timing valve accomplish the hydraulics to lock the converter turbine to the torque converter housing. The overdrive gear ratio is supplied by a third planetary gear set and its overdrive clutch. In direct drive in third gear, the power flow goes through the direct clutch and the overrunning clutch. This very strong spring, rated at up to 800 pounds, holds the sun gear to the annulus for direct drive. For coasting or reverse gear, power flows only through the direct clutch. The simple shift into overdrive or fourth gear is an adventure in electronics and hydraulics. The shift is determined by the SMEC. When the vehicle is traveling in third gear over 25 miles per hour, the SMEC uses the following information to allow the shift. The SMEC checks the coolant sensor signal, 60 degrees Fahrenheit minimum. It also checks the engine speed sensor, the vehicle speed sensor, the throttle position sensor, and the map sensor. In third gear, the power flow comes off the intermediate shaft simultaneously into the planet carrier and the overrunning clutch. The direct clutch holds the sun gear to the annulus under spring pressure for a 1-to-1 ratio. The overrunning clutch carries the power flow during the shift into fourth gear. When the SMEC energizes the overdrive solenoid, the third gear line pressure starts to move the overdrive piston rearward. The piston pushes the sliding hub and begins to compress the direct clutch spring. Now, with spring pressure relieved, the direct clutch is disengaged. Power flows only through the overrunning clutch. As the sliding hub is forced further rearward, the overdrive clutch engages, holding the sun gear to the housing. As power enters the planet carrier, its gears move around the stationary sun gear, so now the engine can turn less for one revolution of the output shaft. The lock-up torque converter is also controlled by the SMEC. Once in fourth gear, the SMEC signals the lock-up solenoid to close, supplying pressure to the lock-up valve. The lock-up valve directs pressure to the torque converter where the turbine is clamped to the spinning torque converter housing. This eliminates any slipping normally attributed to automatic transmissions. The lock-up valve releases the torque converter to normal operation prior to the 4-3 downshift. Well, now that we've seen what the A500 overdrive unit is and how it works, let's go through a step-by-step disassembly and assembly procedure for the A500 overdrive unit, since that is the new hardware.
Before raising the vehicle, place the gear selector in low gear. This will retract the parking rod for easier disassembly. If there is major hardware failure within the overdrive unit, or if the fluid is contaminated enough to cause problems with the main portion of the transmission, then remove the entire transmission. If the diagnosis indicates clutch or governor problems only, then remove only the overdrive unit. To start the overdrive removal, drop the oil pan, drain the oil, and then reassemble the pan. Support the transmission and raise it enough to remove the cross member. Next, remove the speedometer cable. Remove the yoke straps, mark the position of the drive shaft, and remove it. There are 7 bolts securing the 2 transmission portions together. Loosen the 2 cases after removing the last bolt. Very carefully pull the unit off of the intermediate shaft. A bearing and a select spacer may be either on the piston, the sliding hub, or the intermediate shaft. You'll need these to check clearances after reassembly. Once at the bench, tip the unit so that any excess oil drains into a few shop rags. Watch for any sign of abnormal wear, such as clutch material or metal fragments in the oil. Now, this is a very sturdy unit, and you should not expect to be totally disassembling every piece. But in the event of a failure within the overdrive unit, you must inspect each part. Remove the overdrive clutch snap ring. Then pull out the alternating metal and friction clutch components. Take a close look at each clutch component for signs of wear. Next, take out the wave ring. This special ring acts as a cushion to absorb the shock when the overdrive clutch engages. And then there's another large snap ring to be removed. Unscrew the 2 Phillips screws and remove the access plate. This snap ring holds the output shaft front bearing in place. Now, since the entire case must be inverted to remove this ring, insert the alignment tool, Miller Special Tool C6227 and invert the case on the shaft. Expand the snap ring and lift the case off the gear train. Follow service manual procedures and remove the governor and shaft key. Remove the snap ring, then remove the governor housing snap ring. Now you can remove the governor housing with the slip-fit tubes out of the case. Using snap ring pliers, remove the output shaft rear bearing snap ring. Now, by tapping the case on the bench, the bearing should drop out. All right, next, let's remove the parking mechanism. First, remove the reaction plug snap ring. Next, unscrew the bolt securing the dowel and parking pawl. Now, another tap of the case on the bench will cause the dowel, parking pawl, and reaction plug to drop out. At the very rear of the case, a standard A727 rear transmission bushing and seal are used at the output shaft. Now let's take the gear train to the arbor press. It's very important that you use an arbor press, not a hydraulic press, to compress the direct clutch spring. A hydraulic press doesn't have the travel required to perform this critical step safely. Place the output shaft in a fixture which will support the output shaft flange. With the assembly properly supported, place the special tool C6227 in place. Have a helper compress the direct clutch spring. When the hub is compressed, you will now be able to safely remove the larger load retaining ring. And the smaller load retaining safety ring. Now that the direct clutch spring tension is relieved, the rest of the unit can be disassembled. Now lift off the sliding hub with the direct clutch on it. Remove the components of the clutch and inspect them one at a time. Next, remove the direct clutch spring, the sun gear, a needle bearing pack, and the planet carrier. Invert the assembly, and using expanding snap ring pliers, you can remove the overrunning clutch intact with a quick counterclockwise twist. Also, remove this needle bearing. Now index the direct clutch drum to the annulus for exact assembly. Two wire retaining rings secure this direct clutch drum to the annulus, an inner one and one partly under the rear of it. Now the drum slides from the annulus. Index the annulus to the output shaft for exact reassembly. To remove the annulus, one snap ring secures it to the output shaft. Now a light tap with a soft mallet pops it off the shaft. Now the only component left is this output shaft front bearing. Removing it, however, ruins it, and a new one must be pressed onto the shaft. Now before assembling, clean all parts and dry with compressed air only. Cleaning parts with shop rags tends to plug the filter with lint. Now, to assemble the overdrive unit, insert the shaft through the back of the annulus. And secure it with the snap ring. Next, set the direct clutch drum face down and insert the annulus lugs into the slots inside the drum. Insert the rear retaining ring first. Then install the front wire retaining ring to secure the drum. Now hold the overrunning clutch upside down with the expanding snap ring pliers. Place the needle bearing against the back face of the clutch. Now, hold the shaft assembly upside down and with an upper counterclockwise twist motion, install the overrunning clutch. Next, carefully set the carrier assembly into the annulus. And align the splines using the special tool. Next, set the needle bearing in place. Remove the tool and install the sun gear. Place the special tool back into the splines. Set the spring on the sun gear. Then place the sliding hub on the spring. Install the direct clutch plates one at a time on the hub. The next step involves compressing the direct clutch spring with the arbor press. Set the special tool on the hub and compress the spring. Remember, you'll need a helper to operate the press. As the spring is compressed, slide the clutch plates into their grooves and down the hub. Install the large load-retaining snap ring. Now install the safety ring. slowly release the press, ensuring that the load retaining rings are properly seated. Set the gear train aside and then reassemble the parking mechanism. The pawl engages with these large protrusions on the annulus when park is selected. Install the dowel, parking pawl, and spring back into the case. Then reinstall the retaining bolt and torque it to specs. Next, place the reaction plug in and secure it with its snap ring. Set the outlet shaft rear bearing in the case, ensuring that the groove is toward the front of the unit. Then install its snap ring. After installing the governor, install the governor housing and secure it with its snap ring. Now install the output shaft front bearing snap ring in the case. Make sure the alignment tool is reinstalled in the gear train. Invert the gear train and slip the case over the shaft. Expand the snap ring and slip the case down until the ring locks in the bearing groove. Then release the snap ring. After reinstalling the access plate, reinstall the flat ring. Use a large screwdriver to be sure that it's seated properly. Then reinstall the wave ring using the same seating technique. One by one, install the overdrive clutch plates. When the final plate is in place, install the final wire retaining ring to secure it. This overdrive unit is almost ready for installation. However, one measurement should be taken to ensure proper clearance within the gear train. Measure from the sliding hub bearing seat to the facing of the overdrive case. This determines the thickness of this select spacer. If it's within tolerances, you're okay. If not, then choose or select a thinner or thicker spacer to achieve the tolerance required. The other important point here concerns hardware failure in the overdrive unit, such as when replacement of the annulus, the carrier, the overrunning clutch hub, or the intermediate shaft is required. The measurement of new component stack-up for correct intermediate shaft location is critical. To check new component stack-up, measure from the carrier spline shoulder to the facing of the overdrive case. If the measurement is within specifications, everything's okay. If not, however, the measurement will indicate which size spacer should be placed on the end of the intermediate shaft for correct location. Spacers are available in 4 thicknesses. This little spacer is very important to the longevity of the transmission. Then assemble the main portion of the transmission and check the input shaft end play. Adjust the number 3 selective thrust washer according to the service manual procedures for the A999 3-speed load flight transmission. Install the overdrive unit to the main case on the bench. If the overdrive unit required only a clutch replacement or other service not including major component replacement, then the intermediate shaft location set at the factory will be okay. You will, however, need a new gasket. Use a sharp knife and cut the old gasket around the piston. Place the old gasket on the new one as a template and trim the new gasket to fit. Okay. Now you must try not to twist the case while installing the unit. The carrier and overrunning clutch splines will rotate out of alignment. If this happens, you'll need to realign them with a special tool, or you may be required to disassemble the unit and align them again. Align the slip-fit tubes and push the case forward. Install the 7 attaching bolts, snugging them up to the flange of the overdrive case. Tighten the 7 bolts, torquing them to specifications. After installing the drive shaft and the cross member, follow fluid refilling procedures and add the required amount of transmission fluid.
The new A500 4-speed automatic transmission is quite a feat of engineering. And equally so, it's a new and exciting challenge to prove you have what it takes to service this new transmission. Even if you've never serviced one before, the videotape you've just seen will help you tackle the job and do it right the first time. See you next month.